Hi, folks. Welcome back from break. I know it was a bit of a short break. If you've got Bluetooth headphones, you can carry on making your sandwich. As Chuck said, it's a beautiful day here in Michigan. I'm assuming it's pretty nice, full summer where you are. I know I'm wearing cargo shorts. I may or may not be wearing shoes, much like the rest of you. That's the great thing about a virtual conference, but I miss the chance to meet everybody, to have those hallway conversations, to complain about the turkey bacon at the buffet. But what we're going to do right now is we're going to present a whole bunch of posters, which is part of MCBK's mission to connect people, to disseminate information, and all of the authors who are going to spend a minute or so presenting just an abstract of their posters. Would love it if you would show up later and if you would continue those conversations, contact them, take it as an invitation to collaborate. I'll just mention, as Chuck and Rachel have mentioned, that up at the top of your screen, there's a link to select a breakout session to at least start in for the posters. You can switch. You'll have to just talk to the moderators there. So get your pencils and paper ready. We've got a bunch of presenters who are really passionate about their approach to CBK. Let's see, what else do we need to mention? All of these posters, abstracts will be published in the Learning Health Systems Journal. So that's probably enough for me. What you really came here to see were all those posters. It'll be a fun ride. And why don't we cue up the first poster? I think that's going to be Peter Tabor talking about automated cataloging and tracking of public health data around COVID-19.
Thanks very much. My name is Peter Tabor. I'm with the VA Salt Lake City. I'm presenting an automated process to catalog and track COVID-19 public health guidance. The COVID-19 pandemic has resulted in numerous and constantly changing online information sources providing public health guidance. For example, CDC presently has about 130 documents just for healthcare providers alone. Inventorying online guidance is critical to understand what information is available, from where, and who its intended audiences are. We're implementing an automated process to identify COVID-19 resources from all levels of public health authorities. Our process produces an inventory of guidance created by a source organization, an inventory of external target resources referenced by the source, and the frequency that a resource from one authority is referenced by other authorities. The process will support sampling and indexing of online COVID-19 public health guidance. Thank you.
Thank you to the MCBK annual meeting for having us from the Mayo Clinic. Our poster is around bridging the gap between patient data and clinical situations and knowledge through a searchable clinical concept glossary. Our poster is centered around the technical aspects of the CCG and everything that's associated with it. The CCG exposes the semantic and operational definitions of resolvable clinical concepts, and also allows to centralize the computational methods that can be leveraged to answer clinically relevant questions using patient data. An operational definition is a computable piece of knowledge that is implemented by CBK artifacts or can also be deployed as a service. One example is fire service profiles. We build them using a FireStew3 query. We can also build them using an NLP query. The CCG, really the big thing about the CCG is that it allows us to save time, mostly for the developers and the clinicians, which minimizes the duplicative efforts. And a big one is minimizing inconsistent definitions with different groups throughout Mayo going after the same data and maybe interpreting it differently. The meaning of that data and using it differently could be dangerous. And so having the shareable definitions will allow all of these teams to have the same data and using it appropriately. So thank you, and we'll see this later in later session.
Hi, so this is Bikram Dey. So my colleague Rajan and me, we are going to be doing a live demo of our application, which is the SickBay platform. This is fundamentally a clinical system which is used in the hospital for inpatient systems usually, and it collects physiological data, usually in a time series format. So we actually have a clinical problem of data persistence of time series data and a quality problem. So our system tries to address that, and we try and follow the FAIR principles for data. So it is actually a FDA cleared software system for remote patient monitoring and alarms distribution. So we passively record alarms, waveforms, vital signs, and everything, and along with the meds and observations. So we store it in a computable format and the native high fidelity of resolution, as you can retrieve it and do your computation on it. And we also have the tools and APIs to use it for research and for artificial intelligence backends. So this lets us do research and cyclically improve the process of healthcare. So please join us at the actual demo later today. We'll love to see you and have you there. Thank you.
So my name is Lacey Fabian. I'm presenting on behalf of AHRQ's CDS Connect. It is a platform for improving healthcare through clinical decision support. We have been to MCBK before and are excited to be here for the virtual portion. And later today, we'll be focusing on how to contribute to the CDS Connect repository. So specifically the artifacts and what tools are available to make those contributions, and walking through that later today. We hope you can join. Thank you.
Craig, you're up.
Sorry, I got issues with the muting. So I'm Craig Mayer from NLM. And so we took clinicaltrials.gov data and interventions relating to various conditions, and we use data science techniques to essentially run every condition in clinicaltrials.gov and pair it up with all the interventions that have been tried throughout all of the clinical trials on clinicaltrials.gov. And from that, we create a central file that's very granular, and we create different views from that. So looking at things such as what interventions made to phase 3 and phase 4, how that changes over time, different completion status. And we did all of this in looking at various different views and different trends that we can see when it comes to interventions compared to different conditions. And so I'll discuss more in the later poster session when I have more time, these different analysis and results that we did and different thoughts going forward that we can do. So thank you.
Thanks, Craig.
Hi, my name is Sophia Wang. I am an ophthalmologist and informaticist from Stanford University. Our poster is about computing over ophthalmology clinical text from electronic health records in order to develop predictive models using that free text. So our poster will present how we train and evaluate ophthalmology domain-specific word embeddings, and we'll compare the performance of those domain-specific embeddings to kind of general embeddings. We present how we created some custom ophthalmology-specific analogies to evaluate the word embeddings. And then finally, we'll demonstrate how we use these embeddings to predict the actual visual prognosis of the visually impaired patients in our system using just the free text clinical notes documented about them in the electronic health records. So please come to our poster if you're interested in building predictive models using free text in the electronic health records. So to see our approach, so sign up for breakout room 6.
Hi, everyone. My name is Abdurrahman Al-Sheikh. I'm a postdoctoral fellow at Johns Hopkins University. I work with Dr. Harold Lehman. So today I'm presenting about how statistical models are crucial to modern biomedical science because their numbers alone no longer communicate what's going on, especially when dealing with EHR data. There are biases, confounders, mediators, and so on. These concerns are all represented in non-trivial models, so statistical models are crucial. If I'm doing analysis today, I need to find what models are relevant to my work. I can't find them easily today, except by looking into code libraries, so they're not easily accessible. We therefore need libraries of statistical models that in a sense are tagged in a way that make them findable, because most statistical models today are written in specific languages. So models are not easily reusable. In summary, our current regime of statistical models violates the FAIR principles. So we're exploring how FIRE can be used to solve this problem. And I'm happy to talk more about the project. And if you want to hear more, you can join us at the breakout session number 5. Thank you.
My name is AJ Chen. We asked a fundamental question. Can we use CBK to enable real-time clinical collaborations? The solution we have come up with essentially need to solve 2 problems. One is allow doctors in different hospitals to exchange computable knowledge while keeping their patient data local. Number 2, we have to achieve international interoperability easier. As seen in the picture, the CBK platform plus any number of CBK client applications installed in different hospitals form the new CBK network, which we are developing and can be expanded over time. We are focused on 3 use cases now. First, enable real-time clinical collaborations for COVID-19. Second, support international cohort studies. Third, build collaborative learning health systems. I'll be in the breakout session and hope to see you there. Thank you. Bye-bye.
Thank you.
Hi, my name is Sabir Rashid. I'm a PhD student working with Dr. Deborah McGinnis. So my poster relates to this idea that physicians employ multiple forms of reasoning when they're doing clinical diagnostics or therapy planning or plan critiquing. So those kinds of reasoning are abstraction, abduction, deduction, and induction. So by using the select and test model, we're trying to create a AI system that's able to reason the way physicians reason. And our approach to doing this involves constraining each step to one form of reasoning. So we might have a step where we're doing the abstraction to find a relevant problem, and then we're abducing possible hypotheses that could explain that problem. And those hypotheses are then ranked and used to come up with predictions. And then we use what we expect if one of those hypotheses are true to validate our result and narrow down the set of hypotheses which might be used to explain the clinical problem. So I'll be at breakout group 5 if you guys are interested in learning more.
Thanks a lot.
Hi, everyone. My name is Michael Ortiz. I'm a graduate student at UNC Chapel Hill under Javed Mustafa. I'm also an NLM predoctoral fellow. So my poster is on executable search notebooks on the PADI platform. PADI stands for Publication Access Through Tiered Interaction and Exploration. So this is going to be a voice-enabled biomedical information retrieval demo where we're going to display PADI, which is a spatial semantic search engine built on top of the NCBI Entree API, specifically PubMed. And what we're doing with this platform is recording and organizing voice transcripts of search strategies and interactions if the user allows us to. And then we stratify these various data objects into voice commands, intentions, thoughts, and citations that seem to be of interest to the user. And because we serialize them in object notation, what that allows is for all kinds of analytical models or computationally driven models and extensibility on top of the text that you can make shareable and you can collaborate with fellow scientists or students. And in essence, recycling search strategies or reusing search and retrieval operations. And what we're doing is then taking this complex transcript and presenting the idea of a notebook where you can share it through the Jupyter Hub platform. Thank you. I'll be in breakout room 4, by the way.
Thanks.
Thank you.
So hello, everyone. My name is Dr. Williams, and I bring greetings from the Common Data Elements HIV team at the Lister Hill National Center for Biomedical Communications at the National Library of Medicine. And for this year's MCBK submission, we wanted to focus on reproducible case definitions for use in EHR alerts, as well as in cohort studies more generally, using some SNOMED key terms, specifically clinical findings, and the diagnostic billing codes they map to in Athena, which is an Odyssey database of mapped clinical terms. We present a solution for reproducible definitions for EHR alerts and cohort generation. We go further with our poster. Using real world data, we investigate our 100% sample of Medicare and counter level claims to test this out on AMI patients, HIV patients, diabetes, Hep C, and hypertension cases over time. We want to know which codes CMS is using to find these patients, and whether or not SNOMED mapped terms can find the same individuals. So it's a matchup. We want to know who did it better. And if you come to our poster session, you can find out who won.
Thanks a lot.
Okay, hello everyone. It's Philip Scott from University of Portsmouth in the UK. Sorry, it's rather dark in my video. So my poster is about trust in computable knowledge. So we've seen a number of serious incidents where algorithms, well-established algorithms, have been badly implemented, and that has caused scandal and subsequent concern about how safe computable knowledge is. And those are things based on known guidelines, known algorithms. When we think about the CBK concept of open libraries of knowledge objects, that extends the question of trust still further. So in my poster, I'm reporting on an initial focus group that we held back in December last year, where we got together a group of clinicians and patients to get a range of perspectives on trust and governance, evaluation, and what their concerns and priorities were. And in the poster, I'll be explaining the 6 key themes that are listed here and going into the 24 subtopics which arose in the course of the conversation. So this was intended to be the first of a series of focus groups. Unfortunately, the pandemic got in the way, but we hope to be running some more of these in due course as circumstances permit. So I'd love to hear your thoughts on trust in computable knowledge. I'll be in breakout room 5. Thanks.
Thanks. Allison Lieb.
Yep. Hi, everybody. My name is Allison Lieb. My group and I were grad students at Duke University, and our project is focusing on the role that CBK can play in the identification of human trafficking victims. We plan on using our clinical experience and BPM plus health, and we propose developing a standardized workflow for electronic health systems that assists frontline clinicians in identifying and coordinating care for these victims. In doing so, we'll provide explicit clinical decision support to clinicians and enable best practice advisories that can alert staff of benign presenting complaints as high risk for sex trafficking and determine whether to administer a validated screening tool. Additionally, we'll provide a clinical pathway for these identified victims to assist in the necessary care coordination between the healthcare team and local communities. So please join us. We're in breakout room 6 to learn more about how we intend to apply CBK in addressing and resolving this subject area in our healthcare system. Thank you.
Thank you.
Good afternoon. My name is Saifon. I am from the Universities of Utah, and this is a brief overview of the 2 posters. Adrian will present public health guidance for the COVID-19 pandemics, a preliminary qualitative analysis while evaluating COVID-19 guidance from CDC and State Health Department websites. We generated typologies concept through iterative coding cycle, and the code that we generated classify guidance according to settings, stakeholders, topics, and locations. I will present linking COVID-19 guidance for healthcare provider to ELI taxonomy of generic clinical questions. We use ELI taxonomy to organize clinical content into COVID-19 guidance and explore gaps in the taxonomy. We found several topics addressed in public health information during the pandemic that are not represented in ELI taxonomy. Thank you.
Hi, my name's Elisa, and I'll be presenting on linking COVID-19 public health guidance to mesh terms. So this poster is linked to the previous two posters you just heard about, where it discussed our effort to improve the findability of COVID-19 guidance developed by different public health agencies. And given that MESH is an extremely comprehensive database of terminologies, we also decided to link our typology that we created to current MESH terms to not only define their definitions, but also enable connections to other information sources. And in doing so, we have found some potential gaps in MESH, and some of these gaps are found in areas specific to guidance to a wide range of stakeholders. And it's important because promptly establishing comprehensive concept coverage is extremely critical to timely and effective information retrieval during and after a pandemic such as this one. So if you'd like to learn more, please join us later. Thank you.
Thank you.
So I'm Mark Tuttle. I'm a data scientist. My co-author here is Stuart Nelson, who is mainly known in this audience for inventing RX norm. So we're not trying to tell people how to practice medicine. We're trying to make medication indications computable to sort of reduce the cognitive burden on physicians. So basically, we've looked at a sample of a little over 1,000 medication labels, and we've extracted the drug name and the text. And basically, we've developed a logical model, a disjunctive conjuncts, and the model fits 90% of the indications in our sample of 1,000 labels quite well. And the next challenges are how to relate this to electronic health records and standard vocabularies. And I'm going to be in breakout room 3 for those of you who would like to hear more. Thank you.
Very good.
Hi, I'm Jim McMisker. I'm from Rensselaer Polytechnic with Deb McGinnis, and I'd like to talk to you a bit about deontic logic. We are working on trying to represent deontic logic in semantic web technologies, and OWL specifically, so that when so that we can actually compute basically policies, including guidelines, as basically as basically classes in an ontology that ends up actually, where you can classify activities or people into those actual classes. Now, deontic logic is based on modal logic, and so part of this process is trying to reduce the logic within that down to OWL, down to description logic. And part of it is trying to come up with a rephrasing of deontic logic to talk about things rather than being obligatory, they're recommended, rather than being impermissible, they're discouraged. So come see our poster, and we'll talk a bit more about the nitty-gritty of what the actual representation does and can do, and why it's based on a provenance model.
Thanks. Best 1-minute explanation of deontic ontology I've heard.
Good afternoon. This is Pawan Goyal from American College of Emergency Physicians. Our poster is on reducing health IT burden on clinicians and improving health outcomes. Physician societies such as American College of Emergency Physicians, or ACEP, have been in the business of developing clinical policies. Often the knowledge is embedded into PDF or on their website, which is difficult to compute, and it is often challenging to get that guidelines into the clinical workflow. The focus of our effort has been to take the clinical practice guidelines, use a standard approach for business process modeling notation, and convert them into machine consumable protocol or artifacts, so that these guidelines are now available to various software systems and decision support systems. We are currently working on 2 use cases. One is the first trimester bleeding emergencies, and the second is the alternative to opioid for low back pain for patient presenting to emergency department. We have picked cross-functional specialties so that when patient is sent home from emergency department, they have a definitive care pathway that is followed by their final physician. The call to action is we are looking for more use cases, especially around COVID-19, and we will be sharing more information into our poster session. We are into breakout room 5. Please come to our session and we'll be happy to share more details. Thank you.
Thanks very much.
Hi everyone, I'm Shruti and I'm representing a team of researchers from Rensselaer Polytechnic Institute and IBM Research in presenting an effort that we have begun to support different user-centric explanation types for clinical reasoning. We began this project as we observed that clinicians seek different explanations that are not supported in a standard manner in system design currently. And to achieve this goal, we took a 3-pronged approach illustrated by the workflow image on the slide, in which we first surveyed the literature to identify explanation types that address different user goals. And then we conducted a user study to validate and refine the usage of these explanation types in clinical practice. And finally, we leveraged the knowledge we gained through the literature survey and the user study to build a standardized semantic representation of explanations that system designers could use to support various explanation types in their AI systems. To learn more and ask questions about this project, please attend the breakout room 5. Thank you.
Thank you, Peter. And my name is Anna Arlova. I am speaking today on behalf of the Academic and Professional Education Committee of the Business Process Management plus Health initiative of the Object Management Group. It's mouthful, I'm sorry, but in our standards world, we're always using this long statements with a short abbreviation. So OMG, Object Management Group, stands for the Standard Development Organization that works on standardization of business processes. And our education committee at the Business Process Management plus Health initiative is actually focusing on the initiative to bring end users into the information system development process. And by end users, we mean doctors, nurses, public health professionals, and researchers, those who actually users of data that those health IT applications allow us to capture, store, manage, and then eventually use. In our presentation, we will show you our pilot project on developing an educational components that you see here on the slides on the bottom that we are right now piloting together with the students from Duke universities. And you can see their names among our presenters. Ms. Alice Noib, thank you so much for being with us and helping us to develop this important components of both academic and professional education, such as translating the clinical guidelines into the business cases, translating the business cases into the use cases with the standardized representation of computable data flow and workflow, using standards for representing data sets in this context, as well as other standards needed to share this information. And at the end, we will show you the example of using the content management tool in working on this training effort, both in academic environment as well as in the healthcare organization. I would like also to mention and Gwen on our call here today with us presenting. And with that, thank you so much. We look to hear you at the session.
Thank you. And John Fox, you're up. So glad you could join us.
Thank you. Thank you very much. I'm going to talk about Open Clinical, which is a knowledge sharing project and platform that we've been running for a number of years. If you come to the presentation in breakout room 2, I can talk about and I hope demonstrate the platform. But in particular, I'll tell you about the project we started in March, just before lockdown started in the UK, to see if we could capture medical knowledge published by the BMJ best practice in an executable form and deploy it quickly. At that time, we thought the emergency was going to be over within a small number of months. months, but not, of course. We published the first version of the Pathfinder application in April, and made that available to our clinical colleagues for their criticism and assessment. And we wrote it up as a progress report, which has just been published on learning health systems. If you're interested to look at the demonstration, the online demonstrator, please go to the link and you can get the details in the paper. We're now working on Pathfinder 2. Thank you very much.
Thanks very much. And let's just squeeze Peter Haugen as the last, because we have to move on to the rest of the program.
Very, very good. Well, as mentioned, my name's Peter Haug, and I will be talking this afternoon a good deal longer about using HL7 FHIR and a group of, and a standard from the object management group, the business process modeling standard, to build a complex clinical workflow for diagnosing and treating pulmonary embolism. The focus here was both to implement a diagnostic protocol that could be run in the emergency department, and to explore these two different, or these standards from these two different standards groups, from the object management group and of course from health level 7. Punchline is that we successfully created that application, and I'll be talking about it this afternoon as a way to facilitate application interoperability and knowledge portability. I should be in breakout room 1.
Thanks very much. And let me just quickly thank all the presenters. That was really awesome. We do have to run immediately to the next thing, so see you all soon.